Hi, and welcome to Chapter 8. Hopefully you've gotten a pretty good basic understanding of SQL at this point with our select statements, and we're going to move on to actually building our database using create statements, being able to add data to it, modify it once it's created, and add a couple of extra little things. Let's get started. So the first thing that I want to remind you is about schemas. Remember, we talked about schemas before when we were talking about different ways of building databases. And so far, when you've been working with SQL to do Chapter 7, hopefully you've done a lot with schemas, recognizing the different schemas or the different applications that you're using or the different groups of data. So it's really important for you to use your schemas in your database. Obviously, we could build a separate database for every application, but a lot of times in the real world, that's just not cost efficient. Let's go ahead and have 5 different applications with one database, and we'll just break those into schemas. So that's what we're doing with this course. With our schema, the first thing that you're going to be doing is you're going to create your schema. Now, schemas have to be created in their own SQL statement before you can add the individual tables. So we're going to use the create schema command SQL statement that's listed here. It's just create schema and then the schema name. You can include an authorization piece of information to allow certain users or certain groups to have access to different schemas. In this case, I'm not going to worry too much about that. You're going to be building this in your own database, and so the only user is really going to be you and me. So you don't have to worrying about the authorization concept. If you want to look at the schemas that are in your database, you can look at the data dictionary. Remember, we talked about those. That's the one that the database designer uses to see which objects exist in his database. You can do sys.schemas to get the list of schemas, as I have listed here. The default schema for your database in SQL Server is DBO, Database Organization, I think is what it stands for. The DBO database is the default. So if you were to create a table without defining a schema, that table would go under the DBO schema. That's the default schema that it would always be listed under. That's why we use our schemas to separate those out. So if you have added a new table and you forgot to give it a schema, it's going to go under DBO, just to warn you. That's going to be your default database schema that would be there. So when you're creating your tables, remember you have to create the schema before you can use it, and then you can use the schema dot for your table names in your create tables. So when you create a table, it's important for you to understand about data types. And again, these are things we've referenced before, but now it's really starting to get important. With data types, you have options: numeric, character, string, dates. You can do bits or booleans, ones or zeros, and you can do an identifier, which is a 16-character hexadecimal. Lots of different ways that you can do data types, but it's important for you to recognize that. By the way, the character data type has a maximum of 255 characters. Remember, 256 would be 2 to the 8th. So that's going to be how many bytes it's going to use in the database. You can have a variable character, which is variable with a maximum length. If you do a character and you say character with a length of 25, every character is going to be 25 characters with a bunch of white space to fill in the difference. If you use a variable character, it does not fill in that white space. So you could have it be 10 or 12 or 17 or 25. But with character, it will always be 25, whatever length you've told it. So that's the difference between character and varchar. The numerics, you can have decimals and you can have integers, and you can take into account with the numeric or the number with the length of how many characters it is and how many decimal points it's going to store. It's important to keep track of those. If you don't want to just use an integer, if it's a specific type of character or a number, a float that you want to store with only 2 decimal places, go ahead and set those. Set that to be, 7 characters with 2 decimal places. And that's going to control the data a little bit better and make sure that you don't have that unlimited float value that goes on forever and ever. Okay, so your first create table statement. Yes, we have to create our tables. We have to tell SQL this is what the table is going to look like, and we have to give it all of that information that came out of our ERDs to tell it these are the fields that I want in my table. We use the create table statement and we give it a table name, and then we reference that table name. Remember, we need to have the schema name in front of the table name if we're going to not use the default schema of DBO. I'd recommend highly that you use your schemas. That's what they're for. The syntax is going to be the column name with a space, the data type with a space, and then any constraints that are going to go along with that. We're going to explain constraints on the next slide. Be really consistent with your naming conventions at this point. I'm not going to tolerate it when I'm grading if you've got some that are camel case and some that are all caps, some that have underscores, some that use the table name with an underscore ID and some that don't. Be consistent, because it is really, really important when you have your data tables that this is where the consistency matters. This is where it's really important that you get that straight. So you're going to do your create table. You're going to be consistent with your naming conventions, and I don't care which naming convention you pick, just be consistent with it. So if you do it once, do it for the rest of your tables across the board. If you're going to use camel case, if you're going to use lowercase, if you're going to use sentence case, title case, whichever case you want to do, be consistent. Remember that each column needs to have a data type. Think about it. When you're going through your data types, do I want this to be a varchar with 25 characters or 50 characters? Or what about 100 characters? What about the maximum of 255? I have had so much trouble with customers that have told me, okay, this is going to be 20 characters or less always. You'll never have more than that. System will be running for half a year and suddenly they'll go, oh my gosh, the whole thing broke. And I'll look at the code and I'm like, well, yeah, you put in one that was 30 characters long. You told me it would never be less than 25, whatever it was. So be careful when you're doing your varchar. That doesn't say always make them max, but some database designers do because they know that the customer is going to go above and beyond. Sometimes you take whatever the customer told you and multiply it by 2 because you just want to make sure you've got a little bit of leeway there. If you try to run a SQL statement that inserts 30 characters into a field that's only allowed to be 25, it will scream at you and it will break and it will crash your system. It will do bad things. So the database really has to be careful. And remember that being able to be fault tolerant, that's where that NoSQL fault tolerance thing came in, because things like this would happen. We put in 25 characters and it was supposed to be 50, those kind of things. If you want to delete your table, so you created the table and then you realized you did it wrong and you want to do it again, you can't create the same table without dropping it. We use the drop table command, which we will talk about a little bit further on as well, which is just drop table and then the table name, and it will delete the whole table. It'll deallocate it and it'll go away. All the data that was in there is going to go away as well. So be careful. You can't undrop a table. If you drop it, it's gone. But when you're first starting out and you're writing your create statements and you're doing your create table statement, you might get it wrong the first time. You might forget to put in a constraint, or you might decide that you want to change your naming conventions later and you want to go in and fix that. Make sure when you do these, by the way, that you save your SQL statements, because you're going to, well, for this class, you're going to be turning them in. But even if you didn't turn them in, I always save my SQL statements for my create statements, because if something happens and I need to rebuild my database, I want to be able to just run that SQL statement that rebuilds all my tables for me by just running the file. So I'll save it as a SQL file and I'll put it aside and say, these are my create table statements. That way also, if something happens with my data and I need to change something, I'll go in and re-update those and make sure those are right, because it's just one more way of documenting your database, making sure that everything's good. So constraints. There are a lot of different types of constraints that you can add, and we've talked about a lot of these with our ERDs. So you should have kind of thought about some of these concepts as we move along. Starting from the top, we have the ability to be nullable. Is this an optional value? Is this value allowed to be null? And when you create your database, you can say, this is not nullable. You cannot make this a null value. It has to be populated. You can also say that it can be null. This is something that's optional. I don't care if you fill it in or not. This is important when you're inserting your data, because if you try to insert a row of data and you have defined this field to be not null, but you forgot to give it a data value, it's going to yell at you and it's going to say, no, I can't do that. This field is not null. You have to put a value in there. Same time, if you try to put in an insert and you didn't include it and it was nullable, the database will be, that's fine. I'll just put null in there and we'll be fine. Unique. So we have the option of defining a column as being unique, not just a primary key, but unique in and of itself. So this is saying that this can never be the same thing as any other value. Again, when you're doing your insert statement, if you try to put in a duplicate value in there, it'll balk, it'll come back at you and yell. Default values. So again, going with that null and not null concept, sometimes we like to have a default value. If I want to say everybody is always going to be turned on except for the cases where I specifically say turn it off or something like that. The default value is always number one. It's always a type of salaried as employee or employee as salaried. Whatever my default value is. Sometimes it's useful to put a default value, again, when you insert, if you forget to put a data value in that default to get popped in there automatically. So we can have a field that it always has to have a value and then has a default value, so that we always know that something is being populated in there and I don't have to worry about null values when my data comes back out of the database. There is a concept called check, and the check will allow a constraint that says, is this one of the possible values? Is this a number that's less than 1,000? Is this a number, a date that was before, 1920, something along those lines. So we can add specific constraints to our column, which will ensure that that column never beats whatever those records are that we put in the constraint. So it doesn't ever put in bad data. The whole reason we went through our ERD, coming up with all of our different data options, and we started looking at what possible values could be in there, was specifically for this point. Do we want to add a check on that value? Is this something where we're not going to allow the president to be under the age of 35? So we're going to put a check and make sure that your birth date is greater than a certain date, something like that. Adding these checks to your database will ensure that your data always has that data integrity we always talk about. So next we have our primary key and our foreign key. You actually define your primary key and foreign key in your create statement. So in your create table statement, we add what is the primary key. Again, you can have a composite primary key, and that's fine. You would just put in column 1 and column 2, whatever the columns are. Or you could put a single value primary key. But telling the database ahead of time, this is my primary key, will help all of your data queries to run faster. It knows it's a primary key. It knows that this is the field that's going to be going to a foreign key. It deals with indexing, so on and so forth. When you have a foreign key, you also want to put that in there in your create table statement. And you want to say, this is a foreign key. This is the column number, and this is the table that it references, so that I know where the links are going to be with my relationships, and it's in my system. An important part about this is, how does the system handle updates and deletes when it comes to that foreign key? In other words, if I delete the value from my foreign keys table, what do you want to happen in this table? What do you want it to do? Do you want it to delete all the way through and delete this record as well? Or do you want to do something different? So we have the on update cascade option to be able to cascade an update that will cascade through to the other tables that are related to this. If I delete a foreign key, everything gets cascaded on the update. Everything gets cascaded on the delete. So if I change my foreign key in my table, do I want to cascade that update through? So that's something that we can tell our system at this point. Hey, this is a foreign key, this is related to this table, and yes, I want those to be updated. The other thing you can do with a create table is you can add a generic constraint that we just call a constraint. And this constraint has to have a name, because we have to be able to delete the constraint or modify the constraint, so it has to be named so we can do something with it later. And then we can give any type of constraint that we want. So this piece of information has to be unique. It's not a primary key, but it's like two fields together. These have to be a unique field. The example of first name and last name has to be unique, because that's something that we decided in our business rules that we wanted to have happen. So we want to add it in our create table statement to make sure that it gets done in the data. By putting it in our create table statement, the database won't allow you to add data to make it broken. So now that we know what those constraints are, because we went through the effort of doing our ERD, this should be a pretty easy thing to do. Our ERD should already have all of our field names. It may not have the types, but those should be pretty obvious in most cases. The nullable should be related in some way to your optionality. You should think about that when you're looking at your data fields. Is this an optional field or not? And then of course, primary keys and foreign keys, those should be obvious from our ERD as well. And then all we have to think about is any other types of constraints that we want to add. By the way, you can change these after you've built your table. That's okay. You don't have to know them all right away, but you want as many of them as you can in your create table statement for a couple of different reasons. The first is because then they're all done and they're all in order and everything's great. But you also want to be able to save this SQL statement so that you can use it later on. And if you have all these constraints already in there, you don't have to worry about adding and modifying something that's already been built. Indexes. Remember, we talked about indexes as they help the database do its searching or its sorting or joining or doing any constraints on values. These are those values that you ever want to search on. So if we want to do a social security number, we want to search for a last name. Remember, they do not have to return a unique value for the index. We'll talk about the unique and index in just a second. But remember, indexes are more about helping the database know the stuff that you are going to be asking. In an index, we can require that the index field is unique. When we require it's unique, you can't have duplicates in it. That way, an index will always have to return a singular value. So when we build our index and we say create index, we can make it a unique index, but we don't have to. In the notation that I have up at the top, you'll notice that things are in brackets. Those are optional, or they're duplicates. So in this case, we can create an index on the table name with columns, at least one of them. So we can say that there's an index on this column, or you can have multiple columns on column 1, column 2, column 3, and there has to be a comma between them. So this notation is pretty similar across most documentation you'll find as far as SQL statements. So you should be able to see this in the book, and you'll see it when you go search online, these little brackets to say this is optional versus this is required. I am using all caps for keywords, and then I'm using lowercase or camel case for my names, just a heads up. I recommend adding an index for any field that you might join on and any field that you might search on. So I'll add 5 indexes for a table of 12 attributes if I think that's necessary. The indexes have a name so that they can be referenced, so that if we put in an index, then we realize that it was a waste and we didn't need that index, you can drop the index. We need to know what the name is so that we can drop it. So that's why they have names. So we have to give a name for the index. When we do the SQL statement, it's create index, index name on table name, and then the columns that are being indexed. All right, so you went and built your table. Cool. You added in your indexes. Great. Oh crap, I need to change something already because I realized that I forgot to do something. I forgot to add a column. I forgot what the column's name was. I need to change the data type. I need to do something to my columns in my table. I need to change my table. Okay, so we have a concept called alter table. By the way, it's alter, E-R, not altar, like the thing you sacrifice things on. A lot of people will get the spelling wrong on that one, and then they'll try to figure out why they're doing it wrong. Alter is an ER. So alter table takes the SQL syntax of alter table and then the table name. And then what do we want to do? If we want to add a column name, we need to give it a column name and then any constraints that go along with that, that null, that unique, any other constraints. You can add generic constraints. So I can say alter table, table name, add constraint, and then put the constraint in there. And I can also drop things like my primary key or foreign keys or a specific column itself. Maybe I added a column and I didn't need it anymore. I realized that it was a superfluous column and I don't need it and I'm going to get rid of it. You can alter table name, drop column, and you put the column name. So a couple of different ways that you can do that to alter your table. Again, to delete the entire table. To drop the whole table, you just say drop table and then the table name. It will delete it. It's gone. If you had any data in there, sorry, don't do that. So be careful with dropping tables unless you do it on purpose and you know what you're doing. It never checks. It never comes back and says, are you sure? You type in drop table and put your table name, it'll drop it. So those are the alter tables. So we're altering the table. Okay, so now we've built our table and everything's happy with our table. We've added all of our constraints and we've added all of our changes that we needed to make, and now we're ready to start adding data. So we're going to insert some data rows. Generally, when we insert data rows, we insert them one at a time. I know you're thinking, but what if I have 400 rows? Yes, you have to make a different insert statement for each one of those rows, unless we use a subquery, which I'll explain in just a second. So the insert row or insert data SQL syntax is just insert into table and then we can use parentheses to say which fields, and then we use the word values, and then we put in the value list, comma separated. If you are going to insert every single column in your table, you do not need to list them all out, but you need them to be in the right order. So you have to think about, what is the order that I did for my data fields? If my columns are first name, last name, middle, initial, and I try to insert last name, first name, middle, initial, it's not going to put the right data in. It doesn't know which one it is if you put them in wrong. If you want to do the field list, make sure that the data in the field list order is the same order as the value list. Kind of makes sense. The concern that a lot of people run into with databases is when they do the insert statement, if they're assuming that they know what the data columns are. Sometimes you go in afterward and you alter the table to get rid of a column or add a new column or something like that. You need to make sure that your insert statements now still have the same data fields in the same order. This is another reason to insert those data fields in that field list rather than just assuming that you're going to get them right. So these are a couple of insert statements: insert into vendor and then insert into product, where I have listed out the product field names and then the values that go in there. Remember, if you're putting in a string, that it is a single quote, not a double quote. Double quotes in SQL Server don't work. We do single quotes. So everything's single quote. You need to have a semicolon at the end of every one of your insert statements, and it will run them all multiple times. So it'll run insert one row, insert one row, insert one row. Be sure that if you are only adding some of the data fields, that the default values exist for the remaining data fields. This is back to where that is null and default value pop in. So if I have a default value and I want it to be the default value, I don't have to actually put it in my insert statement, because the default value will get populated automatically. And that's fine if that's what you wanted to do. If you had a value that was not allowed to be null and it didn't have a default value and you didn't add it in your insert statement will fail, because it's looking for that data field and it doesn't find it. So think about those when you're creating your data fields and when you're doing your insert statements. Those are important to keep track of. Now, the last line here. Yes, you can add records with a subquery, assuming that the data is in a position where you can subquery it. So a lot of times when you're adding data, you're just adding data and it's not in a subquery. There's no place for you to grab it from. What a lot of people will do is they will take like an Excel spreadsheet or something like that and import the entire Excel spreadsheet and then be able to pick and choose pieces of information out of it, in which case you can use a subquery to populate your database. So that's how you would use a subquery. You would say insert into my table, and then the different fields. And then instead of saying values, you would run a select statement after that, and you would make sure to insert those fields in the exact same order that you selected to get your subquery. So you can do an insert into with a subquery, so you don't have to type out every single thing. All right, so now we've got our table. We added all our stuff to it. We inserted all of our rows. Oh, wait, now we need to change something, because 90% of what you're doing with your database after you build it is changing data, adding data, inserting data, modifying data. So to update a data row, now remember, it's a single record that you're thinking at a time. So I'm going to insert a singular record and I'm going to update that. The SQL command is just update the table name, and then we're going to set an individual column equal to a value. We don't do all columns and then all values the way we did with an insert. We do each individual column is equal to a specific value, comma, another column is equal to this value, comma, another column is equal to this value. Probably the most important part about an update query is that where clause. That is not required. You do not have to put a where clause, but think about what happens if you don't. I'm updating every single value for this column in every record all to the same value because I haven't done a where clause. This applies to every data row that applies with that where clause. So whatever my where clause is going to be which records are changed. Most people, if they're only changing one single record, are going to put the primary key in there. They're going to say where the primary key is equal to whatever the data field is equal to the primary key, because that'll get you to a unique piece of information, a unique row, and therefore just changing that one data value. Sometimes you want to change all of them that fall into some sort of category, some sort of group, where the code is equal to this. I want to change them all from 1799 to 1999. something like that. I want to change the updated date of something. Everything that came in on the 24th, I want to change the status to received, something like that. So you can make that where clause anything you want, but remember, when you do an update query, that where clause is going to limit or control what is being updated. And every row that falls into that where clause is going to be updated with whatever that singular value was that you put in there. Oh, by the way, one thing that you want to make sure you always do every time you do an update, every time you do an insert, every time you do a change, go run a select query afterward and make sure you got the data right. Okay, so we got our data in there, and then we realized that we screwed up and we want to delete all of the data for the 24th because we put it in there wrong and we need to add it differently. We're going to run a delete query, and a delete query does not need you to list out the field names for obvious reasons. You're deleting the whole row. You can't delete individual pieces of information. That would actually be an update query where you would set the value equal to null. But a delete query is going to delete the whole row. We don't need to know the different fields. We're deleting the whole row. So delete from table, and then again, that where clause. If you do delete from table without the where clause, all of the data in the table gets deleted. That makes sense. You haven't qualified it, so you're saying all of the data that falls into the where clause. There was no where clause, so it's all of the data. So your whole table will get deleted. So if you do delete from product, you'll delete all your records from product. I'd recommend don't do that unless you're really intentional on doing that. And then you give your where clause with something along the lines of where the code is equal to this, where the date is equal to the 14th. It's all good. Again, run that select query when you're done to make sure that the change got done the way you wanted it to. That's the basics of writing your basic insert, delete, update, create statements. Sometimes when you run an update, insert, or delete query, you did it badly. Something bad happened. You didn't mean to. You deleted something you weren't supposed to delete. Depending on your DBMS and depending on how your data was created, you might be able to roll it back. So in SQL Server and in most DBMSs, we have the concept of committing that data. What the commit does is it executes, you've already executed your query, but it kind of finalizes that and makes it permanently changed in the database with the word commit. So when you have finished writing all of your update queries, you want to run commit at the end and make sure they're all committed. If you have not run commit yet, you might be able to run the rollback, which will roll back those queries. So if I have updated and I forgot to put in the where clause and I updated everything and I'm like, oh crap, I didn't mean to do that, I can run rollback and it will undo that query because I have not committed yet, as long as you haven't committed. This will make a little bit more sense when we start working with our stored procedures, because you'll be running multiple queries all at the same time inside of a big block of code. And we want to check to make sure everything gets run correctly. You get to the bottom of this. If you had no failures, you had no errors, then you go ahead and commit. But if you did, you might want to roll back stuff. So rollback is the kind of undo button in SQL. Be careful. A rollback doesn't always work, and it doesn't usually go back more than 1 or 2 steps. By the way, create statements are not part of a rollback. They get done automatically. So if you do a create and then you do a couple of updates and 2 deletes and an insert, you can roll back all of those, but you won't be able to roll back to the create, which isn't really too much of a problem. You can just usually drop the table. We will cover more about commits and rollbacks in Chapter 10, because Chapter 10 will work with transactions, which again gets into transactional manipulation of your data, being able to run things in a transaction so that you can roll back those. But the concept of commit and rollback is simply that, yes, we want this all in the database permanently, and oh wait, we made a mistake, let's undo whatever we just did. Okay, so what you're going to find is that there's a series of queries that you like to run, and you run them over and over and over again. And you would like to make them in such a way that you can get them all the time. You don't want to have to keep typing out the SQL statement every time. What we can do is we create something called a view. And the view is technically kind of a virtual table. It can be used exactly the same way a table can in any of your SQL statements. So if you're doing your SQL statement and you're doing a select from table name, I can do a select from view and get the view. And then I can do manipulation on that. I can do a where clause on that, so on and so forth. The nice thing with that is that if you do have a kind of combinatorial query where you're doing a couple of joins, a couple of clauses, where clauses, you're grouping by, you're doing some math in there, and I know I want to use this all the time. We do this a lot for reporting. If you have a report that wants all of this data, I'm going to save it as a view and then just call the view. Go get the view and say select star from view, and I don't have to think about the query again because it's saved and it's used again. So to do this, you do the create view command with a view name. Again, things have to be named. And then we use the keyword as, and then we put in our select query. So create view, my view as, select star from whatever, and all the rest of my query. So that all goes down underneath the create view. When you do that, you can then do select star from view, or select, you can even update the view by updating specific values as well. So views are dynamically updated when the data changes. They're not stored with data values. They're stored as the SQL statement, and then they just run the SQL statement. So everything is done on demand, and they're dynamically updated, obviously, every time the database changes. All right, so we've talked about surrogate key values. So the key values that the system creates for you automatically. In this case, we're going to talk about how we can use sequences to do those. There are two different kind of fields of view that we use for creating primary keys using unique values. One is to use a sequence and one is to use unique identifier. I tend to go with the unique identifier direction just because I do, but sequences work just as well. So what a sequence does is it gives you a starting value, and then it allows you to increment that starting value, and it kind of stores this in the database so that you can ask for the next value at any point and get the next value in the sequence. It's kind of like an auto number where we can start from 1, but you can give it a starting value. So you can say start from 101 or 1001. You know, like when you get your new checks and you don't want to look like you're just starting your new check, your new bank account. We can change our increment value. You can increment by 5s or increment by 10s if you wanted to have invoices look like you have more customers than you do. And then there is a concept of caching. When you do a sequence like this, the database can pre-allocate the next 20 or so numbers just to have them kind of stored there so that they're really easy to pull out and the system doesn't have to go find them. And that's something that you can do if you want to. You don't have to. And caching saves a little bit of time, but it isn't significantly necessary. So we can do cache or no cache depending on your DBMS. Oracle uses the table sequence.nextValue method, and SQL Server uses the next value for sequence. Just a little bit of different syntax depending on what it means. If you want to find all the sequences that you have created, you can use, again, that's that data dictionary, the system table dot sequences, and you just select star from sequences, from syssequences to get all of your defined sequences, and it'll tell you what the next value is, what the incrementer was, what the starting value was, so on and so forth for your sequences. This way, when we're doing our insert for our values in our table, I can just say get the next value in my sequence using it this way. Again, if you want to use the next ID using a unique identifier, that's allowed as well. Sequences are useful if it's something that you want to be a number that you reference. But the good thing about sequences is because they automatically auto increment, you don't have to worry about them not being unique. It won't let you put in a different value than the next one as long as your code is written right. So here's where we kind of shift gears a little bit, and you're going to look at me and you're going to go, but wait a minute, this looks like code. This looks like if-then statements, and this looks like do-whiles, and I'm really confused because you told me we couldn't do code in SQL. Yeah, okay, so you kind of can. These are called procedures, and so PL SQL is Oracle's version. It's a procedural language in SQL, and Transaction SQL or T-SQL is the one in SQL Server. They are both programming languages in SQL, and they do have the ability to declare variables, and they do have the ability to do if-then statements or do-while statements. We're going to talk about this in about 3 more slides when we start getting into procedures, but yes, you can write code in SQL. In fact, there is a lot of times that you're going to have to just to make your business logic work. Remember how we talked about business logic and we said you couldn't do it all in SQL? You can't, but you can do it in Transaction SQL, or you can use it in the PL SQL for Oracle if you have an Oracle database to do a lot of your business logic to make sure that in the situations where this occurs, did you do this as well? Did you check this? Did you update this? Don't forget to make sure before I give the student the next rank in the karate class that he has passed all of his requirements. So I can go check the requirements, make sure that they're filled in. This is that business logic that you're going to add in that just says, I need to check all these other little things that isn't really data specific, but I want to check my database and go over different options. So we're going to talk about different things that you can do with your T-SQL or your PL/SQL in databases to be able to get through some of that business logic. The first one we're going to talk about is triggers. And this isn't like triggering you to go hide in a corner. This is triggers because whenever something happened, I want this to happen as well. Triggers are useful to make sure that your data stays accurate and they automate your business logic. You can rely on your entire application, which is written in, HTML or JavaScript or whatever you're going to do on the front end if you have a website, or in C# if you're going to do a web app or a Windows app. But a lot of times it's good to have these things in your database because you want to, again, make sure your data integrity stays intact. You don't want to break your data. So triggers can occur either before or after something happens. And the something is either a delete, insert, or update of some data. So before I delete the data, I want to go check something. After I delete the data, I want to go delete any other option or any other references to that data. After I update something, I want to go check something. Before I update it, I want to make sure that I'm adding the right data. Did I check to make sure that this wasn't a duplicate value? Did I check to make sure that the data was still intact if this occurs? So I can do either before or after delete, insert, and updates, or when triggers occur. So what we do with a trigger is we say, okay, either create or replace the trigger. So in other words, if you've already done the trigger, I want you to replace the one that's already there. But if you haven't done it, then I want you to create a new one. Give it a name, trigger name. You want to tell it whether it's before or after the event, and then what's the event. So before delete, after update, however you want to do the event. And then it's going to be on a specific table because we're going to be updating that table or deleting in that table. And we're going to be saying, okay, we have done an update on this table. Now I want to go check something else, and I want to go verify something. So after I have updated or before I have updated my data, I want to go do something. And that's where I'm going to have this begin and end. And this is going to be my procedure. Inside my procedure, I'm going to be running some code. I can choose if I want this to run on every row that's in my table, or if I only want it to run on the table. In this procedure, I can start asking some questions. Did the right data, did I cause something wrong with my information? Did I do something with this update that broke something? Did I break some business rules somewhere in here? The next slide on stored procedures is going to help you to understand that syntax a little bit better. Always remember, in this situation, you always want to put semicolons at the end of each statement, because between your beginning and your end is a series of statements. So for our triggers, we're going to do a create or replace, the trigger, the keyword trigger, and trigger name. Before, after, whichever one we want to use, delete, insert, update, and then the table name that we're referencing. So with a stored procedure, you can create a stored procedure, which can also be stored on your database in and of itself. So I can say in my trigger, I want to execute my stored procedure, and that's a statement, and you can do that. So a stored procedure is similar to a function or a method that you would be writing in some code. So if I had some code that I wanted to verify some data, I can have a stored procedure that just says, go verify my data. And it can take arguments, input and output, so it can return values and it can take them in. So I can have arguments that I can use. Those arguments need to be given a data type, and they need to know whether they're coming in or going out, whether they're an input or an output. You can also have variables that exist in your stored procedure that you're going to be using as well. So this is a way of using variables. We're going to talk about variables in a minute, but variables, when we use them in SQL Server, we always use the keyword declare. And variables start with an ampersand. We always put an ampersand in front of variables when we declare them, so that SQL Server knows that those are variables that we're using and not keywords and not data fields. Data fields do not have to be in brackets, so obviously if you put a variable, it doesn't know the difference between a variable and a data field, and it'll get confused. So we always put an ampersand, so the @ symbol, before a variable. So you say declare at variable, and then what data type, integer, boolean, whatever it's going to be. Then on the second line underneath that, you're going to set the value of the variable if you want to set it at this point. So you can say set variable equal to 2. We can also set the value of the variable using the into method. We can select some piece of information, employee ID, and we can put it into our variable. So select employee ID into at emp ID as my variable, and then finish my SQL statement from employee where last name is Jones. And that'll take the employee ID as long as it is what we call a scalar variable. It is a single value variable as opposed to multivariable. So you can use the into as well to populate a variable. When you do your stored procedure, there's a lot of examples in the book on stored procedures. A lot of them are using the PL SQL from Oracle. We're going to be doing a little bit more in this class, kind of in a separate little thing, probably in our class meeting, to cover stored procedures. But you can always search online to look for different types of stored procedures and how they work. At the beginning, you may not really understand why you would need them. You've got data, and why do I need a stored procedure? As we go along and as you do your homework, you're going to see why we put stored procedures in. And hopefully you've got enough background in coding to understand when we say we want to do an if statement, you're going to use the syntax of if, some constraint. You're going to use the then. So for SQL Server, it's if then. Then we're going to run this statement. And so we're going to do if this record already exists in the database, we're going to update it. And if it doesn't, else, then we're going to insert it, because there's a difference between insert and update. So you don't want to insert a new value. We want to check in our stored procedure before we update this value whether or not this person already exists, whether this customer exists. If they don't exist, then create a new customer and put them in there and insert it. And if they do exist, then update the one that's currently in there to whatever data values I'm giving you. So this is how we use our stored procedures. You can use the execute stored procedure method inside of a trigger, or you can use it inside of other stored procedures. So you can have a stored procedure that calls another stored procedure, nested stored procedures. And then those are stored by name, and they can just kind of sit there in the database, and anytime you need to use one, you can pull it out and use it and execute it, and then go on. You can send it parameters the same way you would with a function. One of the things that we do like to do inside of our stored procedure is we like to be able to maybe loop through pieces of or record sets. So queries. So I want to do a query of all of my students, and I want to, set any student who has more than 10 tardies equal to, on probation because they have too many tardies. So I'm going to set their status. I need to walk through all of the different values of a record set to do that. How do you do that inside of my SQL statement? Well, we use something called a cursor. And what a cursor does is it allows you to run a SQL statement, get the result value of that SQL statement, and then go through each value individually and make decisions. So I could do the declare cursor, give it a name, and then do my select star from students. So all my students. Cool. Then I have to open my cursor, just the way you open a file. And I want to fetch the next one from my cursor. So fetch the next row. And I'm going to put it into a variable which I can then reference. The same way that you would if you opened a file and you wanted to read the next line and store it as a new line. So we're going to store it in as a record that I can then reference. As long as that fetch status is not 0 or is 0, then keep going. So in other words, the fetch status was good. I think fetch status goes to -1 or something like that when you get to the end of the cursor. And then I can do a series of statements. I can say, okay, well, select whether or not, this, and store that as a variable. If the number of tardies was greater than 0, then update, otherwise keep going. And I can do actually walking through my record set this way using a cursor. Cursors can be useful. They can also be kind of confusing. So just think of it as it's a way of getting your query, getting your record set, and being able to walk through that data to get the pieces of information that you need so that you can decide if this, do that, in situations where this occurs, do this as well. Okay? All right, so we talked about stored procedures, but we didn't talk about functions yet. There are a lot of functions. We've covered them already, the built-in functions that already exist. But sometimes you want to make a user-defined function. You want to make a function that you want to create and you want to do something special. In this case, what I've done is I've taken the date and I've formatted it as month/day/year just by taking my date and plopping it in there, because this is something that I want to do often. Now, yes, in this case, there actually is a method that'll do that for you, that's built in. You can use the format method to do that with a date time, but I wanted to show you how it would work. So in this case, if I wanted to do something specific with a date, I can take an input just like you would with a normal function. So your parameters, your arguments, and I want to create my function with its name. And don't forget to put it in a schema if you want it hanging out in a schema. What its return value is, and then again that begin and end. I threw the word go at the end of the end because I wanted to be able to immediately use it when I ran this. So in this case, I have declared a variable. You can see I did at return value and I made it a varchar of 50. I set my return value equal to the string compilation of month, day, year with slashes. And then I returned, using that keyword return, my return value. When I call select get formatted date with the date as whatever from my prescription, it will take those values, run it through my user-defined function. User-defined functions are by and large really inefficient. They're not really good things to use, but they will give you exactly what you want. So if you have problems with efficiency, if your code starts to run really slow, if your queries start to get really, really hectic, you might want to look at the use of your user-defined functions and see if there's a way around those, because those are by definition less efficient. But they're also really, really useful if you're using them one-off and you're using them in specific situations. Okay, so that was a lot of information. This chapter is like 70 pages long. There's a whole lot of examples and a whole lot of information, but the basics of what I just went over. Use your schemas. Schemas are great. How to create a table, try to do it right the first time. Try to make it so you don't have to alter it later. But when you do, this is how you do an alter table. Insert, update, and deleting of data including the rollback and the commit concepts. We talked about views and sequences. So views being user-defined queries that you can store and then reference directly. And then sequences that we use to get those auto numbers. Triggers, which are inside that procedural language, along with our PL SQL and our T SQL, our stored procedures, cursors, and functions. Whole lot of things going with this one. You're going to need it all to get to the next step. So please try to read through the book, understand how each of these works. Go back and rewatch the video if you need to understand all of those. And then we'll talk about your homework. All right, in the review, most of it, I skipped a couple because I thought they were kind of superfluous. 2 and 3, we skipped 4. 5 through 8, we skipped 9, and then 10 through 12. Please, when you're doing your homework, write it in your own words. I know sometimes it's really easy to just skip back to the book and then write word for word what's in the book, but it's really annoying as an instructor to read your answer and know that it's exactly the same that's in the answer key, because I don't care if you can regurgitate the information. I want to know if you mean it. Do you understand what it's asking you? So please try not to just copy the definitions from the book. Tell me what you think it actually means and give me examples that makes more sense so I know that you're really understanding it. And the problems. So it looks like a lot. I actually skipped most of it. We're going to have each of the students have their own database by now. So if I have not talked to you directly about how to get to your database, if you haven't found the reference to it on Teams, call me or send me a chat and we will make sure that you get hold of your database. But I've created a database for every student in Azure. It's similar to the same way that we connect to my database, the GFC MSU Simpson database, but you're going to have it under your name as the database name rather than the GFC MSU Simpson one. You don't have create state abilities permissions on my database, so that was intentional. I don't want you to be able to go in and delete all the work that I've done. But you will on your database, and other students will not have access to your database. You won't have access to theirs. So this is your clean database. You can add anything you want as long as you at least do the requirements. So we're going to start with the construct company schema. There's questions number 1 through 15. Use the construct company schema. I have included the SQL data file that actually came with the book. about how to add the base tables to your database. Make sure that you add the schema because the schema will not be in there. So you have to actually go through and edit that SQL file before you run it to add the schema in there, the construct company schema. Otherwise, they'll all go under DBO and you might get confused as to which ones go with which. Make sure when you do items number 1 through 15 that you do them in order. They build on each other. Each one of them requires the previous one to be done, so you can't do them out of order. Save all your SQL statements because you're going to be turning them into me. But I will also be checking your database to make sure that you actually executed your queries. Okay, and then I also included a couple on triggers and stored procedures. So the sale company 2, again, you will have to create the schema and you will have to add the data tables that are in D2L so you can get that data file. There's not a whole lot of them for this one, but you will be building your triggers and your stored procedures for this one. Make sure that you save that SQL statement so that you can submit those to me. Save them in a text file. Please don't copy and paste them. I mean, you can copy and paste, but don't screenshot because I need to be able to run them as well and make sure that the SQL is straight. So that'll be good. Okay, so these you're going to be doing in your own database, not in my database. You can still reference my database if you want to, but there's nothing in there for you really. Just to make sure that you got stuff done. Please call me or ask questions if you have any questions. We're going to have this one due Thursday this week instead of the Wednesday, just to give you one extra day just to kind of get the feel of it. And hopefully you guys have some fun. Have a great week.